Thank you all for coming. Really excited to be here and to talk about a couple of cool topics with myself and my partner in crime, Audrey. We'll be talking later. Azure Databricks is a really hot topic these days, and it kind of crosses different types of technology. So I'm going to be focusing more on the compute side. Audrey's going to be talking more about the storage. So the two go together hand in hand. I'm going to focus a little bit on Azure Databricks, getting a quick introduction into what it's all about, a brief history of Spark, and just a little bit of understanding how that ties together with Databricks and AI that we have over at Microsoft. And then I always, if anybody has seen me talk in the past, I always like to do a demo because nobody actually just wants to see me talk. So I do have a little bit of a demo where we're going to do a live image recognition deep learning model using some photos, and we'll get to that in a little bit. So that'll be sort of the end of my discussion. And I think we can continue. So quickly allow myself to introduce myself. My name is Ahmed Sherif. I am a TSP in data and AI at Microsoft. I've been there for about 7 months. I started out in data back in 2005. And then I started migrating slowly into more data science, machine learning projects. And lately, in the last couple of years, I've really been digging deep into Spark. And Spark has really been sort of the go-to big data platform for computation on the big data side. I recently wrote a book called Apache Spark Deep Learning Cookbook, which has basically recipes to get started on Spark and especially on the deep learning side. And that's one of the reasons why I find Databricks very, very useful in the sense that it gets you started with Spark with minimal barriers. And that is one of the things that people in the past have had issues with Spark on. If I was to describe Spark in one sentence, I would use the term that the people who created Spark said, and it's basically they were a group of engineers in around 2010, and they started the Spark project to basically democratize the superpower of big data. And they wanted to unify three things that people would always talk about with big data, but would have a hard time really showcasing. And that was machine learning, ETL, streaming data, and doing big data querying on billions and billions of rows. The brief history of Spark. Spark started in 2010 at the Berkeley Lab, and it's not that old if you think about everything that's happened in those 8 years now. Spark was really, at first, it was open source, it was free, it's still open source, but nobody wanted to use it when it was open source. So the creators at Spark were trying to give it away for free, and nobody would take it. And it wasn't until they realized that people want to wring someone's neck when something goes bad. And if it's open source, nobody takes responsibility for it. So they decided to create a company around it, around Spark, and sell it as an enterprise platform with support behind it and with maintenance. And they started Databricks in 2013 to do that. And from that time, Spark has kind of grown with Databricks. And in 2015, they released a version of Databricks that introduced data frames and data sets with machine learning pipelines. And that's really what changed the game in terms of doing big data machine learning on data sets that were rivaling hundreds of millions and billions of rows, which you can't really do, even though they have laptops now that are much more powered and supercharged. Those are just some things that you're going to run up against some limitations. Right now, currently, Spark is on version 2.3, and Databricks is on version 4.3, and that's as of this month. So as we were talking about, Spark basically is the unifying platform that allows you to do a lot of things within one singular platform, as opposed to what you would do in the past. So previously, if you wanted to do streaming, you would do something like Kafka. If you wanted to do machine learning, you were doing it on Python or R locally. Deep learning, you were running your neural nets for that primarily. If you were doing Spark SQL, or if you're doing SQL on big data, you would use something like Hive or Pig or Impala, and these were all working within silos. The benefit of Spark is it brought all that together and allowed it to be a singular core framework to do. So whereas on the big data side of the storage, everything kind of diverged from Hadoop, on the compute side, everything is sort of converged on Spark. So if we look at Databricks from a quick overview, when it was created in 2013 in the AMP Lab, they became the largest contributors to Spark. So while Spark is open source, they were pushing about 75% of the code into it. So most of the vision of where Spark was going was being guided by the team at Databricks. So they had an incentive to keep it going in the way they wanted to. So they were able to kind of push it in the direction that it is now. So while there are other big data platforms like Hortonworks and Cloudera and MapR that sell managed Hadoop and managed Spark offerings, they're not contributing to the vision of where Spark is now as Databricks is. Azure Databricks is basically Databricks as a first-party service on Azure. So unlike with other clouds, it's not an Azure marketplace or a third-party hosted service. And it's basically sold as a platform as a service or a PaaS offering. And so that's the nice thing, is that it can integrate seamlessly with Azure storage. It utilizes Azure Active Directory, so your security is passed down. And also it eliminates the need to get different billings for different usages of your time that you're using it. As far as the key audiences and benefits of Databricks. So most people automatically associate the data scientists with the usage of Spark on Databricks. And really it was more of the data engineer and the ETL folks who embraced it first and found it as a useful tool to navigate within big data, the big data platform, and doing ETL and bringing sort of the unstructured and big data sets into some type of a structured reporting format for users. Once they did that, the data scientists then came on board after them and started leveraging sort of the machine learning capabilities on top of Spark. So if you go back earlier to my sort of timeline, you'll see that machine learning was really introduced later on in terms of the data science process, and the ETL side was what kind of came on first. Additionally, Databricks has some nice visualizations and features that allow even people who are on upper level management be able to get access to it without having to deal with all the code and the stuff that looks very foreign to them. So VPs of analytics, CTOs, CDOs, they're all able to sort of see the output of what you're doing within the Spark platform without having to really understand all the underlying code behind it. So it doesn't look like a bunch of gibberish. Azure Databricks also has notebooks. And they're not just slightly older versions of your college roommate's Jupyter notebook. How many people here have used Jupyter notebooks in some capacity? How many people here have used Spark just by itself? How many people have used Spark on Databricks? Okay, so about maybe a third of the room. The nice thing about Jupyter Notebooks is it gives you sort of an integrated development testing platform to be able to see some of your work visually. The problem with it is they have to code it all. So you might be able to pull some data in, but then you have to visualize that. You have to visualize it using something in R like ggplot, or Python has matplotlib. These are all ways to visualize your data, but you have to use code to do that. Databricks is nice in the sense that it takes that out and it lets you visualize that just with the click of a button. Additionally, it allows you to create your notebook and add comments and collaboration between what you're doing and what other people within the same network are doing on those notebooks. And the visualizations are not just like bar charts. You can create maps just by clicking a button and selecting the map icon if you have data that's geographically based. All that stuff is done, visualizations within HTML. And so it's not something that, that's something that can be exported out and visualized externally outside of the Databricks platform. Also, when you create a Jupyter notebook, usually you're selecting some type of language behind it with the kernel. So it's either a Python kernel, Python 2, or Python 3. It's an R or Julia or Scala notebook. The nice thing about Databricks notebooks is it allows you to create a notebook that's affiliated with a default language, but then you can take a different cell right underneath it and code in a different language. So if you wanted to start off with Python, do some manipulation, take that data frame in Python, send it to R, do some manipulation within a library that R lets you do very easily, take it back, maybe do some filtering or some joining within SQL, and then finally pushing it out to some visualization. That all can be done within one notebook without having to jump out of it and go somewhere else. So that kind of puts an end to sort of the discussion in terms of, do you need to know one specific language to work within Databricks? You can get by with just one perfectly fine, but it gives you the opportunity to leverage all of them within one kind of tool set. So if you think about them as tools and not languages, it becomes a whole different experience. Additionally, you can use these notebooks as Markdown to do like HTML editing. And you can look at Databricks file systems and what you have in your folders, as well as being able to execute shell commands within the notebook. All that stuff within the notebook itself without having to go outside and doing that stuff separately. Azure Databricks and AI, machine learning, deep learning, and transfer learning. So how many people are familiar? I'm going to assume most people are familiar with machine learning and deep learning. How many folks are familiar with the term transfer learning? 1, 2, okay, that's good. We'll talk about it as well. So the nice thing about Spark is it comes with, or Databricks, it comes with Spark ML-lib, which comes pre-installed with the Azure Databricks platform. And then it has Spark ML, which is basically the API that sits on top of the data frame for Spark. So all the stuff that you can do with H2O, sparkling water, scikit-learn, XGBoost that you were doing on Python or within the R machine learning libraries, you can do them natively on Spark, but you can also bring in your old libraries that you were using within Python code and transfer it there as well. Makes it convenient to sort of do some lift and shift approaches. Additionally, you're able to use pre-trained deep learning models that have already been gone through the training process, and you're just leveraging the output of that to take your data and append upon it. So you're kind of piggybacking off of the hard work that other people have done. These deep learning pipelines are actually native to Databricks. So they have built them themselves, and they allow them to be used within their platform. Same way you would add a library for TensorFlow or Keras in your Jupyter notebook. So transfer learning is sort of the combination of the best of custom AI and pre-built AI. So imagine if you had, if you were a really good, I'm using tennis because I play tennis. So if you, or I played until I hurt my ankle. Imagine if you had a good tennis swing and you wanted to see if you could transfer that skill set to golf. The same thing would be, I've heard that actually doesn't work very well, but I'm just using it because I found this image online and this guy looked like he knew what he was doing. So I used that as an example. So you're taking your skill set that you've built in one area and you're seeing if you can translate it into another area without having to do all the work. So this has happened with a lot of people over at Berkeley and in Stanford and at Google and at Microsoft, is that they built these pre-trained libraries and they have very mystical names like ImageNet and Inception v3 and ResNet 50. And they've trained thousands and hundreds of thousands of objects ahead of time. Houses, cars, boats, you name it. And they've done all the pre-training on it. And what they want you to do is leverage the backend that's already been done and then come all the way right in the neural network, right towards the end. And instead of using the images they have, you add your own images. And you see how well it can detect those images. So that's kind of the exercise that we're going to do in a minute. So those are some of the most common ones. And that's what they refer to as transfer learning. So it's one of the few things in the data science world that actually makes sense in the way that they've described it, in the sense that it actually explains what it means without having to go into too much detail. ResNet, or exception, was one of the ones that was used by the Microsoft team in 2015 that was actually able to make detections better than the actual human eye in one of the international image recognition tests. Inception v3 was created over at Google. They say that one is the best pre-trained model, or the most well-rounded pre-trained model in the world. Although when I used it for my demo, it did not give me as high a accuracy rate. So I found another one, and because in demo land you just want to use what makes you look good. But if you want to, I could put that in and see what the accuracy would be for that one. So basically, in summary, what we learned is that in 2010, Spark was like the Napoleon Dynamite before he met his brother's girlfriend, and he looked like this guy here. And then in 2013, Databricks came along, and it became like after he got that video cassette, that tape cassette player from his brother's girlfriend, and then he never looked back. And anybody here who's under the age of 25, a video cassette is one of those things that they used to actually listen to music, and you can actually dance like Napoleon Dynamite as he was Spark on Databricks. So any questions on that? Otherwise, I can kind of show you a quick demo of what we can do with Databricks pretty quickly.
All right, so when you log into Azure Databricks, you basically have a very similar look and feel that you would have when you are in a Jupyter notebook. Left-hand side, you have your home page where you're able to see your common tasks, recent documents you've opened, as well as some documentation for importing data, connecting to databases, and so on. What we're going to do is we're just going to go ahead and we have a cluster already created, so I've already fired it up by clicking the start button here. And I'm going to attach this cluster to the notebook that I'm working on. If we did not have a cluster, we would come in here and we would create a new cluster. And this would be basically the basis for the amount of compute that we're going to add to our notebook. But I already have a tutorial here for doing some image detection. I'm going to go ahead and go back here and show you guys the data that I have. As you can see, this notebook is already attached to the cluster. So I'm just going to go ahead and leave it be since it's already attached and it's running. Next thing I'm going to do is I'm going to go ahead and execute some cells by hitting the Shift and Enter button. And here we can see that we're using versions 2.3 of Spark. Next thing I want to do is I want to reference the image folder that I'm holding the Ronaldo and Messi files in my database. And they are right here. So I'm going to go ahead and click on it, and I've assigned a link to the folder. I can then go ahead and look at the folders I have set up for the Messi images. And we can see here the Spark job is running. And here are my Messi images, and you can kind of see them in terms of the name and the size of each image. And I'm going to do the same thing with the Ronaldo images. As you can see, it comes in as a spreadsheet, but one of the nice features that Databricks has is it allows you to do some visualizations without having to code anything. So I'm going to go here and just click on bar chart, and I can create a bar chart from the data without doing any coding at all. Very nice feature that allows you to do some very simple visualizations. I can do this again on this data set here and have, for example, a bar chart or a donut chart, and you can go in here and change it around if you want and make it based on average instead of the sum. The nice feature within Databricks is you can create a dashboard off of this data without having to do any type of coding. So I can come in here and click on add to a new dashboard, and it adds it in there. And I can give this dashboard a name and call it Cool Dashboards. And I can go back to my notebook and come down here and say, let's add this awesome donut chart to Cool Dashboards. And if we go back to Cool Dashboards, we now have two charts together. And we can go ahead and hit Present Dashboard and get our dashboards nice and up and running. Just a cool feature that you can do to sort of get an idea how to create dashboards from scratch and visualize the data for upper management without having to take it out and build a more of a structured dashboard like a Power BI. Anyways, I digress. We'll continue here with the data that we have. We're going to do some simple SQL and image reading. We're going to bring in some libraries to do some of that reading, because what we want to do is we want to be able to create a model that can detect Ronaldo and Messi images and see how well they can create them. So what I'm going to do is I'm going to bring in these libraries, and as you can see, we're using TensorFlow in the backend. And it says here, TensorFlow is an open source software library for data flow programming across a range of tasks. It is a symbolic math library, so it gives you all this new cool stuff right on Wikipedia. You can get that information without having to even leave. So some nice features that you can get out of Databricks. So what I'm going to do is I'm going to label these images. I'm going to say all the Messi images, I'm going to label them with a 1, and all the Ronaldo images, I'm going to label them with a 0. And that's kind of what I'm doing here, is I'm creating a column called Messi, called label, and Messi DF is going to be the Messi data frame, and Ronaldo DF is going to be the Ronaldo data frame. So now if I'm going to go in here and just going to create a display Messi DF, and we can see while it is running, this is going to be a big data frame because it's extracting image structure. It's extracting the origin, the height, the width, the number of channels, all that stuff it's getting out of the image itself. But it's also getting the see all this information it's pulling out of it, and all the way in the very end, if I can just hover towards it, let me see if I can, will even let me, it's so, yeah, it's not even gonna let me do that, but you can look here and we can just say, get me, show me the, we'll do a bar chart here, and we will put the plot options, and I'm just going to say, give me the label. So labels are going to all be 1. And, oh, where did we do that? Yeah, all the labels are going to be 1. That's kind of how you know that all 30 images of Ronaldo, all 30 images of Messi are going to be 1. All right, now let's go ahead and do some minor transformations here, just to kind of see how you can do transformations using both Python and other coding skills within SQL. So if I want to know, like, if I want to group by the image height of each image, I can use Python scripting here, basically to say, give me the image height, group it by it, and then give me a count by descending or by descending row count or count of appearance here. So this is basically what we call Python scripting. As you can see, 183 pixels comes up 9 times, and 180 comes up 1 times. So if you add all these up, it should be 30. So this has got 9, 16, 20, 22, 3, 4, 5, 6, 7, 8, 9, 10. Yeah, 30. So these are the 30 images, how they're ranked up. But you could say, hey, I don't really want to do Python. I'm not a really good Python guy. Well, we can take the data frame that we just created. We could push it out to a temp table or a temp view. And we can run the SQL instead and get the same exact output that we had here. We can get it right here. Notice that I have to specify this as SQL before I run it by saying %SQL, because if I don't do that, it's going to think it's Python, because this is a Python notebook by default. So if I run any other code, I have to explicitly state it. So if I took the % away, this SQL header grays out. If I go ahead and run it, %SQL, like this, and execute it, now it's going to execute for me. It's going to execute it for me in SQL script. So we're going to go ahead and let that do that, and we'll see what we will get. And lo and behold, we get the same. The height 183 here, up 9 times, which is the same that we got up here, 183 9 times. So pretty cool. Basically, you can run your transformations in many different languages. Now we're going to do our split our data into 50-50. Now, since we're doing transfer learning for this, we don't need to use as much data for training. And so I'm going to take 50% of my images for training and 50% of them for testing. And that's what I'm doing here with the random split. I'll go ahead and do that. I create 4 data frames, and I'm going to combine the training data frames into one, and I'm going to combine the testing data frames into one. So now I have 2 data frames. Really, that's about the extent of the transformations we're going to need to do. The last part that we're going to work on is we're going to create a model, and we're going to take a pre-trained model that had a big neural network, and we're going to take the last strip of that, the last layer of that neural network, and we're going to freeze that one, and we're going to use, instead of using the images that we're already pre-trained on, we're going to use our 30 images of Ronaldo and Messi to be able to test on our other 30 images and see how accurate it is. So here is where the part where we're going to bring in some models for classification and to create our pipeline. And all the code that we're going to do for the training is here in 3 lines. This is where we're setting up our pipeline, and then we're just going to train our model. I'm going to go ahead and do that right now. And it looks like our job ran, and it took about 30 seconds to run. Now we're going to evaluate our model accuracy against our testing data. We're going to see how well we're going to get. So drum roll please. And since I'm the only one here talking to myself, I will just do my own drum roll. Alright, and we're going to go ahead and see how well we did. And it's running it right now. And it's coming back. Let's see how well we did. I'm going to predict an accuracy of at least 90%. How about that for predictions? That's pretty high. That's a pretty high standard there. And it looks like our accuracy is 93.75%, which is pretty good. That means we probably missed about 1 or 2 images incorrect. Let's see how we did. I'm going to do a crosstab here to get a type 1 and type 2 prediction and see how well it is. We'll run this and we'll see what we get. And it looks like we got 16 Messi images correct and none of them incorrect. And we got 14. Well, we got 14 Ronaldo images correct and none of them incorrect. We had 16 that were correct for Messi, but 2 of them were misclassified as Ronaldo. So those are the 2 that got us wrong, that got us down to 93.8%. Still a very good score. So why don't we look and see which one of those images were the ones that came incorrectly. So I'm going to do a little bit of test to see how close we were in accuracy. Well, it looks like it came back here. It looks like these 2 images are the ones that came back incorrectly. Number 26 for Messi and number 19. Number 26 was way off. It only gave a 7.4% accuracy that was Messi. And this one here said it was only a 34% chance that it was Messi. So those were the ones that were off. Everything else is accurate. So let's look and see if we can see those images and get an idea of why they could have been off. All right. We're almost done getting the file name of the ones that were incorrect here. So here they are. So now I'm going to display the first one that was incorrect. And here it is. And the second one that was incorrect is right here. So these were the two that were incorrect. This one here, I have a feeling this one was wrong because there were 3 people in the image. And even though it's a clear shot of Messi, you don't really tell if these may have caused some type of a contamination in the image. This one here, you know, this one, it could have been something he was doing with his hand gestures that may have detected that this could be a Ronaldo picture. You never know. You'd have to go back and look and see some of the features that were being identified. But overall, I think for building a transfer learning model, only 15 or 30 images for training and 30 images for testing, I think we came up with a pretty good model here to do some Ronaldo Messi detection.